This video is about review for complex numbers. Consider the complex number u equals -1 plus square root of 3i. By finding the modulus and the argument of u, show that u equals 2 times e to the power of 2 pi over 3i. For complex number, this is a a, this is a b. Modulus r equals square root a squared plus b squared. So we get -1 squared plus square root of 3 squared equals 2. Next step, u equals, we will take this 2 out. -1 over 2 plus square root of 3 over 2i. This is a cosine theta, this is a sine theta. We use sine theta to decide the reference angle. Let's talk about the reference angle. When opposite side is square root of 2 over 2, the reference angle is 45 degrees. Which is pi over 4. If the opposite side is square root of 3 over 2, then the reference angle alpha equals 60 degrees, which is pi over 3. If opposite side of this reference angle is 1 over 2, then the reference angle equals 30 degrees, which is pi over 6. We will use the imaginary part of a complex number to decide the reference angle equals pi over 3. Let's draw this Argand diagram. -1/2. This is the square root of 3 over 2. Reference angle alpha equals pi over 3. Then the argument of u theta equals 2 pi over 3, because here is the rule. For special angles, pi over n for the first quadrant. Second quadrant is n minus 1 pi over n. Third quadrant, n plus 1 pi over n. Fourth quadrant, 2n minus 1 pi over n, or negative pi over n. Since this question is a show that you have to draw this Argand diagram to show this theta equals 2 pi over 3. So u equals 2 times e to the power of 2 pi over 3i. For argument of u equals, for any complex number z equals a plus bi, then the reference angle alpha equals arctangent absolute value of b over a. Then in the first quadrant, this argument theta equals alpha. Let's label the quadrantal angles. One complex number in the second quadrant, the argument equals pi minus alpha. In the third quadrant, this argument equals pi plus alpha. In the fourth quadrant, this argument equals 2 pi minus alpha. You can also make an argument into negative angle. For fourth quadrant, this theta equals negative alpha. For the third quadrant, this theta equals opposite of this, which is alpha minus pi. If reference angle is special angles, then we can use pi over n for the first quadrant, n minus 1 pi over n for the second quadrant, n plus 1 pi over n for the third quadrant, 2n minus 1 pi over n, or negative pi over n for the fourth quadrant. Negative angle in the third quadrant, you can get opposite of this, 1 minus n pi over n. For example, if you have 2 pi over 3, then negative 2 pi over 3 will be in the third quadrant. So when we are looking for argument, we always figure out this reference angle. Tangent function is increasing in first quadrant. That's how you remember tangent 30 degree, tangent 45 degree, and tangent 60 degree. Tangent 30 degree will be 1 over square root of 3, which is square root of 3 over 3. Tangent 45 equals 1. Tangent 60 equals square root of 3. You could say the value is increasing. Therefore, for this alpha equals arc tangent square root of 3 over 1, which is 60 degree, equals pi over 3. Since this complex number in the second quadrant, so argument of u equals pi minus pi over 3, which is 2 pi over 3. Since this question, we need to show that the argument is 2 pi over 3. So you need to show this step. Therefore, for this u equals 2e to the power of 2 pi over 3i. B1. Find the smallest positive integer n such that u to the power of n is a real number. We will use this De Moivre's theorem to work out u sub n. U equals 2 times e to the power of 2 pi over 3i. Therefore, u to the nth power equals 2 times e to the power of 2 pi over 3i to the nth power. Then equals 2 to the nth power times e to the power of 2 pi over 3 times n times I. When we are dealing with u sub n is a real number, we need to change this into polar form. Equals 2 to the nth power, parenthesis cosine 2 pi over 3n plus I sine 2 pi over 3n. Since u to the nth power is a real number, which means this imaginary part equals 0. So we set up sine 2 pi n over 3 equals 0. Let's go to unit circle. CST. So n equals 3 because sine 2 pi equals 0. B2. Find the value of u sub n when n takes the value found in part B1. U to the third power equals 2 to the third power times e to the power of 2 pi I. 2 pi is here. So e to the power of 2 pi I equals 1. So we get equals 8. Let's go to C. Consider the equation z cubed plus 5z squared plus 10z plus 12 equals 0, where z is a complex numbers. Given that u is a root of the given equation, find the other roots. z1 equals u equals -1 plus square root of 3i. Or we can write down Euler form 2 times e to the power of 2 pi over 3i. Based on the conjugate roots theorem, z2 equals -1 minus square root of 3i equals 2 times e to the power of -2 pi over 3i. Whenever you see the questions related to the roots, you got to use this sum and product of roots of polynomial equation theorem. A sub n equals 1. A sub n minus 1 equals 5. A sub 0 equals 12. Let's use sum. z1 plus z2 plus z3 equals -5 over 1 equals -5. So we have -1 plus square root of 3i plus -1 minus square root of 3i plus z3 equals -5. Simplify. -2 plus z3 equals -5. So z3 equals -3. Or if you want to use a product formula, Euler form is better. If z equals r times e to the power of theta I, then its conjugate equals r times e to the power of negative theta I, 2 times e to the power of 2 pi over 3i times 2 times e to the power of negative 2 pi over 3i times z3 equals -1 to the third power equals -1. -1 times 12 over 1. So we get 4 times e to the power of 0i times z3 equals -12. This is 1. So z3 equals -12 over 4 equals -3. You can use either one to figure out this z3. Let's go to C2. By using a suitable transformation from z to w, or otherwise find the roots of equation 1 plus 5w plus 10w squared plus 12w cubed equals 0, where w is complex numbers. Let's compare these two equations. Z to the third power is changed into 1. Therefore, both sides divided by z to the third power. We got 1 plus 5 times 1 over z plus 10 times 1 over z squared plus 12 times 1 over z to the third power equals 0. 1 over z equals w. We got 1 plus 5w plus 10w squared plus 12w third power equal to 0. In other words, this w equals 1 over z. Therefore, w1 equals 1 over z1, w2 equals 1 over z2, w3 equals 1 over z3. We know z1 equals 2 times e to the power of 2 pi over 3i. z2 equals 2 times e to the power of negative 2 pi over 3i. z3 equals negative 3. So w1 equals 1 over 2 e to the power of 2 pi over 3i, which is 1 over 2 e to the power of negative 2 pi over 3i. Let's go to eigen diagram. Negative 2 pi over 3 go to the third quadrant. Since reference angle is pi over 3, so this line closer to y-axis. Let's label negative square root of 3 over 2, negative 1 over 2. So we get 1 over 2 times negative 1 half minus the square root of 3 over 2i equals negative 1 over 4 minus square root of 3 over 4i. W2 equals 1 over 2 times e to the power of negative 2 pi over 3i, which is 1 over 2 times e to the power of 2 pi over 3. Go to this eigen diagram. Since reference angle is pi over 3, so hypotenuse closer to y-axis, square root of 3 over 2, negative 1 half. So we get 1 over 2 times negative 1 half plus square root of 3 over 2i, which is negative 1 over 4 plus square root of 3 over 4i. W3 equals 1 over negative 3, which is negative 1 over 3. D. Consider the equation z squared equals 2 times z star. This is a conjugate of z, where z is complex numbers. Z is not equal to 0. By express z in the form a plus bi, find the roots of the equation. Z equals a plus bi. Then z star equals a minus bi. A plus bi squared equals 2 times a minus bi, a squared plus 2abi plus b squared I squared equals 2a minus 2bi. We know I squared equals -1. So we will move everything to the left side. Remember, change the sign. A squared plus 2abi minus b squared minus 2a plus 2bi equals 0. Then we put real part together and imaginary part together. A squared minus b squared minus 2a plus 2ab plus 2b I equals 0. Then we will set up the real part and the imaginary part equals 0 separately. A squared minus b squared minus 2a equals 0. And 2ab plus 2b equals 0. Let's solve the second equation first, because it's easier. Take 2b out. A plus 1 equals 0. So a equals -1. Then we do the substitution to the first equation. -1 squared minus b squared minus 2 times -1 equals 0. 3 minus b squared equals 0. So b equals plus or minus square root of 3. Therefore, z equals -1 plus or minus square root of 3i. This will be the solution to the equation.